Hello, this is 8-2 Part 2. We're continuing with factoring using GCFs. Now sometimes the GCF can be a binomial, and this would be called a common binomial factor. But what we do is pretty similar and actually probably easier than what we were doing before. So here would be an example with a common binomial, and you can kind of see pretty easily that x plus 2 is in both terms here. So what we can do is we can factor out the x plus 2. And then what I have left over, well, I have a 5 when I take away the x plus 2 there, and then I have a 3x when I take away the x plus 2 there. So my factored form would be x plus 2 times 5 plus 3x. Okay, same thing here. The b squared plus 1 is the common binomial factor, and then I'm left with negative 2b plus, and then since there's nothing left here, we would just write a 1. Okay, so that would be my factored form of that. Now notice here that we don't have a common binomial factor, okay, and so we can't factor out anything really. So what we would do is we would just leave it like it is, and we would say cannot be factored. Now what that leads us into is a technique called factoring by grouping. Okay? Now we use this technique when we have a polynomial with 4 or more terms, and this makes it a lot easier to factor things. So we'll look at this first example here, and what we can do, the reason it's called factoring by grouping, is that we can actually take and group. We can do it pretty much in any order we want to, but I'm going to group the first two and the second two. Now if I look here at the first two, I'd want to figure out what their common factor is. So I'd have 6h to the 4th, which is 2 times 3 times h times h times h times h, and 4h to the 3rd, which is 2 times 2 times h times h times h. So it looks like their common factor is going to be 2 and then 3 h's, so 2h to the 3rd, so that's going to come out front. And then I'll be left with 3h minus 2. Okay, now we can do the second part. What's the common factor here? Well, I have 12h, so that's 2 times 2 times 3 times h, and then I have 8, which is 2 times 2 times 2. So it looks like my common factor here, I got two sets of 2's, so that's going to be 4, so that's going to come out front. And then I have 3h minus 2 left over. Now notice here that I have a common binomial factor, so what I can do then is bring that out front, and then here I have a 2h to the 3rd left over plus 4. And so now I've factored that polynomial back to where it started, 3h minus 2 times 2h plus 4. And that's how factoring by grouping works. Let's look at another one here. So again, let's group the first two together. Now as we get good at this, we'll be able to see the common factor without having to make our list every time, and that's what we'll want to get to eventually. So here, like when I look at this, I see that 5 is the greatest common factor between 5 and 15, and then y to the 3rd, y to the 4th. Okay, well, y to the 3rd is the greatest common factor between the y's. Now, if you can see that, then that's great. If you can't see that, you need to make the list, okay? So if I take out a 5y to the 3rd, I'm going to have y minus 3 left over. Now here, it looks like I can take out a y. So then I would have y minus 3 left over. Now notice again, I have a common binomial factor, y minus 3, so I can factor that out. And then I have 5y to the 3rd plus y. Okay, now we also will come across sometimes what we call opposite binomials. And this would be an example here where I have like 5 minus x and x minus 5. They're kind of similar but not quite. So if I take a negative 1 out of 5 minus x, okay, factor out negative 1, that would turn it into negative 1 times x minus 5. So sometimes we'll need to use that little trick there when we're factoring by grouping, and here's what that looks like. So if I take this and I group the first two, group the second two. Okay, the GCF here is going to be 2x squared. Hold on a second here, my mouse is not working. There it is. Okay. Get back to the pen. Okay. Sorry, let's get rid of this. Okay, so if I group those first two, 2x squared comes out, so then I have x minus 6 left over. And here I could take out a 3, so then I'd have 6 minus x left over. Now notice that these are close but not exactly the same. So since these are opposite binomials, what I can do is factor a negative 1 out of here. Okay, so essentially this would become 3 times negative 1 out front, and then x minus 6. So then I can take away the x minus 6, and that leaves me with 2x squared. Well, and then 3 times negative 1 is negative 3, so minus 3. So that's how I would factor if I had opposite binomials. I have to take a negative 1 out of one of them, which is just essentially going to change one of my signs. Notice it would have been plus 3, but now it's minus 3. Okay, so that's what it means to factor with opposites. Let's look at another one there just so we can get a good idea of what it looks like again. So here it looks like I could take out a 5x squared. That would give me 3 minus 2x. And here I could take out a 4, and that would give me 2x minus 3. So again, you see I got opposites. So I'm going to take a negative 1 out of this first one, so it's going to become negative 5x squared. And then I got 2x minus 3 plus 4 times 2x minus 3. So now I have common binomial factors again. I could take those out. Then I have negative 5x squared plus 4 as my second one. Okay, so that's how that works. Factoring by grouping and then also using the opposites. As always, let me know if you have any questions on this tomorrow, and I'll see you then.